Good evening, everyone. Welcome to today's session. Today, we'll be starting with logical reasoning, which is again an important topic when it comes to paper one. Usually, 5 questions out of 50 questions are asked based on logical reasoning. The topic is difficult, but only if you do not understand the concepts. If you know the concepts, then these questions are such that if you know the concepts, then your questions will never be out of the syllabus. At least 4 of them would be within what is the syllabus, because you just have to apply the concepts. It's not like topics like teaching aptitude or research aptitude or ICT, where there's a lot of scope of taking questions and theories from outside. The syllabus here is limited because the concepts need to be understood. If they are understood, then you can solve the questions. At least 4 out of 5 can be solved. Okay? Maybe there is one question that you are not able to solve, provided you have remembered all the concepts which I'm going to share here or which are involved in the subject. Okay. So far we have covered 8 of the 10 topics. Logical reasoning and ICT are the 2 topics that we need to cover. In logical reasoning, we will start with basic terms. Then we'll talk about deductive and inductive reasoning, syllogism, immediate reference, mediate reference, fallacy, mood and figures, and lastly, Indian logic system. Pramanas and Hetavbhas are topics, the main topics in Indian logic system. So we'll start with basic terms. The first term is statement. What is a statement? A sentence that is either true or false, but not both. The earth orbits around the sun. Okay, the earth orbits the sun is a true statement. The Pacific Ocean is the largest ocean on the earth is a true statement. 2 plus 2 is equal to 5. This is false. However, it is still a statement. It's a mathematical statement, but it is still a statement. What is not a statement, an example is close the door. It is a command. It cannot be true or false. The next concept is premise. Please pay attention because the entire logic of the logical reasoning is based on these terms. They'll keep on repeating again and again. If you don't know what a premise is, you cannot go further. What is a premise? A fact or assumption used as the starting point in an argument. It supports the conclusion. For example, premise 1, all birds have feathers. Premise 2, a sparrow is a bird. Premise 1, all plants need sunlight to grow. Premise 2, this is a plant. Premise 1, no reptiles have furs. Premise 2, a snake is a reptile. So a fact or assumption used as starting point in an argument, it supports the conclusion, which is our next term. What is the conclusion? The end result or claim that follows logically from the premises. Premise 1 is all birds have feathers. Premise 2, a sparrow is a bird. So the conclusion is, therefore, a sparrow has feathers. Same for the second example. All plants need sunlight to grow. This is a plant. Therefore, this plant needs sunlight to grow. No reptiles have fur. A snake is a reptile. Therefore, a snake does not have fur. These first 2 statements are called premise, and the final statement is called a conclusion. Next is inference. The mental process of drawing a conclusion based on evidence or reasoning. For example, the premise is there are dark clouds in the sky. What's the inference? It is likely going to rain. Just a moment. Another example, the streets are wet and people are carrying umbrellas. So what we can infer from it, a conclusion that we can draw from it is, it probably rained recently. That is why the streets are wet and people are carrying umbrellas. Argument. Now this total group of premises and conclusion, which is meant to prove a point, is called argument. Premise 1, all mammals breathe air. Premise 2, a whale is a mammal. Conclusion, therefore, a whale breathes air. This entire set of 3 statements is called an argument. 2 other examples of a set of sentences which together make argument. Premise 1, all even numbers are divisible by 2. Premise 2, 8 is an even number. So the conclusion is, therefore, 8 is divisible by 2. Premise 1, all bachelors are unmarried. Premise 2, John is a bachelor. Conclusion, therefore, John is unmarried. I would give you a moment to look at the slide and absorb this. Okay. Statement, something that is true or false. Premise, a fact or assumption used as starting point in argument. Conclusion, the end result that follows logically from the premise. Inference is the mental process where you draw conclusion from the premise or the evidence or the reasoning. And this group of premises and conclusion is called argument. Now let's start with our first topic, deductive and inductive reasoning. We'll take both of them one by one. What is deductive reasoning? Deductive reasoning is top-down approach. It starts with a general statement or theory and then moves to a specific conclusion. Deductive arguments are truth-preserving. If the premises are true, then the conclusion must be true. Okay? The format is from a general principle, a specific case or an example is there, and from there you move on to conclusion. Let's take an example so that you can understand this better. All mammals are warm-blooded. Okay? The statement says that all mammals are warm-blooded. A whale is a mammal. Therefore, a whale is warm-blooded. It is certain that all mammals are, it is certain. It is saying with surety that all mammals are warm-blooded. And the flow goes in a way that it seems certain and logically valid. That is why it is deductive reasoning. Now to understand how inductive is different, let's take inductive reasoning. It uses specific observations to make a general conclusion. It is probable but not guaranteed, whereas deductive reasoning is truth preserving. Inductive reasoning is used in scientific research. You form hypotheses, you think of things which may or may not be, and then based on your findings, you decide what's true. The format is there are specific cases, there's a pattern or observation, and finally what comes at the end is general conclusion. For example, the sun rose in the east yesterday. This is an observation. Second observation, the sun rose in the east today. So your premise one, just to make it easy to understand, I've used the word observation. These are your premise. That the sun rose in the east yesterday, the sun rose in the east today. Conclusion is the sun always rises in the east. It is plausible, but not certain because we are basing it on our observation. However, if the first statement said that the sun rises in the east, it's a statement, it's a fact, a general fact. Now, if that statement was true, the sun rises in the east, the sun rose in the east today, we can conclude that the sun always rises in the east because it is given as a statement. But here it is given in the form of an observation. To show you one more example. I have seen 20 swans and all of them are white. I have seen 20 swans, all of them are white. Based on that, I conclude that all swans must be white because so far all the swans that I have seen are white. However, it's false because black swans are there in the world. Okay. Now let's see the second example of deductive reasoning. All humans are mortal. Socrates is a human, therefore Socrates is mortal. All humans are mortal, a fact or statement is given. It's not that so far I have observed that all humans are mortal. It's not an observation. It's a statement. Okay. Third example. Observation. My friend Ravi, who is from Kerala, loves spicy food. My colleague Meera, also from Kerala, enjoys spicy food. My neighbor Arun from Kerala eats very spicy meals every day. Conclusion, people from Kerala probably like spicy food. Okay. Based on this example, you can understand that inductive reasoning is based on observations. Whereas in deductive reasoning, statements are like all fruits have seeds. A mango is a fruit, therefore a mango has seeds. Clear with the difference between the two? Is the slide visible for everyone? If it is not visible only for one person, it means your network is probably, the network bandwidth is low. Okay. Okay. So here, let's practice. Premise 1, all mammals have lungs. Premise 2, a whale is a mammal. Conclusion, therefore a whale has lungs. Now, is this first set of arguments deductive or inductive? If it's deductive, write A. If it's inductive, write B. Okay. Premise 2. Every time I water this plant, it grows better. Conclusion. Therefore, watering helps this plant grow. Is this deductive or inductive? A for deductive, B for inductive. Okay. It is inductive. The first one was deductive. Third, the textbook says this formula always works. Premise, I applied formula to the problem. Conclusion, therefore my answer should be correct. Is this A deductive or B inductive? It is not inductive, it is deductive. Why? Formula always works. You focused on the textbook says, but the statement is about the formula always works. I applied the formula. So it has worked for me. The answer has to be correct. Okay. So first one is deductive, second one is inductive, and third is again deductive. So once we are clear with the concept of deductive and inductive, now for deductive arguments, there are two things that need to be done. First is validity and second is soundness. Now what are these two parameters? An argument is valid if the conclusion logically follows from the premises. So far, for all the examples we have seen, there was nothing which looked crazy. It was logically following, regardless of whether the premise is true or false. If I say that monkeys are white in color, this is a monkey. So my conclusion has to be this is white in color. Whether monkeys are actually white in color or not, that is not related to validity. Validity is concerned with whether the arguments are logically following or not. For example, all cats can fly. My pet is a cat, so my pet can fly. Logically, it is a valid statement, even if it is factually incorrect. Logically, it is valid. The structure is if P is Q and P is true, then Q must follow. If P is Q, cats can fly. If P is true, that is my pet is a cat, P is true, then logically Q has to follow. My pet can fly. Validity tests the logic, not factual correctness. Another example. If it rains, the ground will be wet. It is raining, so the ground is wet. Possibly true in real life also if it is raining. But there is a possibility that there is a roof on the ground. Okay? If the premise 1 is true, then this has to be true. But is this true or not? We don't know. However, the arguments follow logic. That is why it is valid. All cars are animals. Tesla is a car. So Tesla is an animal. Logically valid, factually incorrect. That is validity. Clear with the concept of validity? Okay. Now let's go through the second concept. Again, this is for deductive arguments. Soundness. An argument, a set of premise and conclusion, an argument is called sound if it is valid and all the premises are actually true. Two requirements. First, it has to be valid. It should follow logic. Second, both premises or whatever number of premises are there are true. Only then the conclusion or that argument can be said to be sound. All humans are mortal? Yes, they are. Socrates is a human? Yes, he is. Socrates is a mortal. This is both valid and sound. Here, all cats can fly. My pet is a cat. So my pet can fly. Valid, but this is not sound. All mammals are warm-blooded. A dog is a mammal. So a dog is warm-blooded. Valid plus all true. Okay, another example of a sound argument is all squares have 4 equal sides. This shape is a square. So this shape has 4 equal sides. Clear with the concept of soundness? Validity plus true premises. That is called a sound argument. Clear? Everyone? Okay. Now for inductive arguments, there are two similar two concepts. They are called strength and cogency. But see, Deductive arguments are based on truth and facts, so they can have validity and soundness. But for inductive arguments, they are based on observations. Invalid statement for deductive argument. Yes, I will. You will get it. Today in the session, there will be statements where you will know whether they are. Just let me finish the concept of strength and cogency. While summarizing, I'll give you the opposite example also. It's there. It will come to you in form of questions in few minutes. Okay. Strength for inductive arguments. So just like validity, forget comparison with validity, because in inductive arguments, we are talking about observations. So now an inductive argument is called strong if the conclusion is highly probable based on the premise. So the premise is the sun has risen in the east every day in recorded history. Therefore, the sun will rise in the east tomorrow. Not guaranteed, but highly likely. Because every day in the recorded history is a huge data for observation. Another example. Okay, another example will come with cogency. So now cogency is where the argument is strong and the premises are true. Then it is also called cogent. Most cats dislike water. My cat is like most cats. Therefore, my cat probably dislikes water. Now, cats dislike water is not a fact that is given here. So we cannot say my cat dislikes water. Most cats is given. There's a high probability. So that's why my cat probably dislikes water. True premises plus strong logic. Now here, an example of strong but not necessarily cogent. 95% of students in this school play basketball. Raj is a student, so he probably plays basketball. Raj is a student in this school, so he probably plays basketball. Strong because the probability is high. But we don't know if this premise that that 95% of the students in the school play basketball is actually true. We do not know that. That is why it is not cogent. It is not something like cats fly in the sky. We know that that does not happen. So we know that the premise is untrue. But in this case, we are not sure of it. It's not given that the premise is true. Okay. Another example. Every winter for the past 30 years, this lake has frozen. This lake will probably freeze this winter too. Now, because the data is there for 30 years, it is strong because it is based on a repeated pattern. And if the past weather data is accurate, it is cogent. It may also be cogent. Provided that every winter, the past 30 years, this lake has frozen is a true premise, then the conclusion is cogent. Another example. All observed swans in Australia are white. You are visiting a lake in Australia with swans. The swans you see are probably white. Strong plus true for the given region. That is why it is cogent. A weak argument. I met 3 people from Sweden and they were rude. All Swedes must be rude is the conclusion. The sample size is too small. 3 people is a very small biased sample. And this is most likely to be a false premise. Based on 3 people, you cannot talk about an entire nation with millions of people. So that is why it is not cogent. Clear with the concept of strength and cogency? Strength and cogency comes with inductive arguments based on observations. Clear for others? See, if your concepts are clear, you will be able to solve the questions without any stress or extra preparation in logical reasoning. Okay. Now let's go to validity. All cars are animals. My dog is an animal. So my dog is a car. All cars are animals. My dog is an animal. So my dog is a car. That is not a valid argument because logically it does not follow. For someone who asked example of invalid argument, think of it. All cars are animals. My dog is an animal, but does that really mean my dog has to be a car? No. It's like saying Dhara is a teacher. Her husband is a teacher. So most probably their parents are also teachers. Is there any logic in this? I am a teacher, my brother is a teacher, so my parents are also teachers. That's not logical. So it's logically invalid statement. It has to follow the line of logic, like given in the examples here. Who asked it? Shivani. Clear? Okay. So you can take a screenshot of this. So when you want to revise concepts, you can use this. Valid, sound, strong, cogent. I'll give you a moment to look at it. Okay. So based on this concept of deductive, inductive, valid, sound, strong, and cogent, we move forward. Evaluation of argument. So how do you evaluate the argument? 3 questions. Is the reasoning solid? Are the premises true? Does the conclusion logically follow? Are the premises true or acceptable? You need to ask, is the evidence factually accurate or at least possible? For example, all dogs bark is more acceptable than all birds bark, right? Based on our general knowledge, we know that birds do not bark. So the possibility of all birds bark is very low compared to all dogs bark. So all dogs bark is an acceptable premise or a true premise. All birds bark is not acceptable. Is the reasoning valid if it is deductive or strong if it is inductive? So for deductive, you ask the question, do the premises guarantee the conclusion? And inductive, do the premises make the conclusion probable? Are they true enough? And the last question is the argument sound or cogent? That is, you see, if it is deductive, then it is valid plus true premises. And for inductive, it is strong plus true premises. These are the steps for evaluation of argument. So basically applying what we have learned so far, that is called argument evaluation. A good deductive argument has valid reasoning, true premises, and sound argument. Similarly, for a good inductive argument, strong generalization, large sample, and it is strong and cogent. The opposite, flawed inductive argument, I met 2 Canadians and they were rude, so all Canadians are rude, is a weak generalization, small and biased sample, weak and uncogent. Okay? Now, types of arguments. We have understood what an argument is. There are premises, there is a conclusion. But now when we are talking of different kinds of arguments, there are several kinds and there are questions asked based on what kind of argument it is. So we need to know, you will be able to understand it just using basic sense. For example, if it's an authority argument based on authority, then it is citing a credible expert or a source. Dr. Kalam said education changes lives. Therefore, education is powerful. It's an inductive type of argument. Analogy is when you compare two similar things to draw a conclusion. And it is also an inductive type of argument. Like heart is important for body, engine is important for car. Or like heart runs the body, engine runs the car. Therefore, the conclusion is engine is vital for a car. This is an inductive statement based on an analogy. Given in the statement form, you will see the use of words like or similar to or same as. Statistical, based on a data or a sample to predict general outcome. It is also inductive kind of argument. Why I'm sharing whether it is inductive or deductive? Because questions have been asked based on that. 85% students use smartphones. Therefore, most students use smartphones. Based on statistics, the conclusion has been made. Definition, argument based on definition, based on the meaning of a word or a concept. It is usually a deductive argument. A triangle has three sides. Therefore, this four-sided shape is not a triangle. Okay. In any case, if it has four sides, it cannot be a triangle. It's most probably a parallelogram, rhombus, quadrilateral of any kind. Elimination, ruling out all options except one. This is also called deductive argument. Ravi is in office or home. If he is not in office, then he is at home. That's the conclusion. Clear with these 5 types of argument? We have more to go. Clear? Okay. Next, cause. Suggesting one event that leads to another. Reason for something. Okay. Causal argument. Again, this is inductive. Smoking often leads to lung issues. Therefore, smoking causes cancer. Now, because often is used, you realize that it is based on observation, and this may not be true for everyone. Mathematical argument, based on maths or logical formulas. Again, because it is based on maths and formulas, it is deductive argument. Like 5 plus 3 is equal to 8. If 5 plus 3 is equal to 9 was written, then it is false. 8 2s are 16. Therefore, 5 plus 3 is 8. And 8 2s are 16. Therefore, 5 plus 3 into 2 is equal to 16. This is a mathematical argument. Arguments based on principles. It applies a general, moral, or a legal, logical rule. It could be deductive or inductive based on whether it is a law or whether it is a moral value. Cheating is wrong. He cheated, therefore he did something wrong. This is based on moral principles. Signs. Using physical signs as indicators of some things. Now, physical does not mean our body, but rather things that we can touch and see. Streets are wet. Therefore, it probably rained. That way. Like when you see the streets are wet, it's a physical thing which you can see or feel or listen. Clarity. Argument based on clarity or plausibility. Preferring the simplest or most reasonable explanation. Now, because it is the most reasonable explanation, again, it is inductive. Power went out after the storm. Therefore, most likely, storm caused it. Okay? Higher probability of it instead of a part malfunctioning. That way. Clear with this 5 types of argument? Okay. 3 more. I don't know if we can actually classify the last 2 as types of argument, but knowing what it means is important for you because this have come as options in the questions. Predictive argument is where you predict a future outcome based on past or present observations. That's an inductive type because you are predicting something which may or may not happen. The observation leads to probable conclusion. It rained every day this week. Therefore, it will probably rain tomorrow also. Categorical syllogism and hypothetical syllogism. Okay, so see, there are 3 kinds of syllogisms. We will 3 kinds of propositions. We'll learn about that after a few minutes. But right now, just learn about this. A categorical syllogism is where deductive reasoning using statements. Just give me a moment. I'll probably have to teach that to you first. Okay. See, a proposition is a statement that has truth value. It is either true or it is false, but it cannot be both. There are 3 kinds of propositions. First, categorical propositions. They relate 2 classes or categories, like all dogs are mammals. Two classes, dogs and mammals, are related to each other. That is why they are called categorical propositions, 2 categories. And maximum questions of logical reasoning, this syllogisms and everything is based on categorical propositions. Hypothetical or conditional propositions, if-then format. If it rains, the ground will be wet. And the last one is disjunctive. That is either or. Either the battery is dead or the bulb is broken. So 3 kinds of propositions relating to categories, which are called categorical, and they are the ones which we will talk about the most in today and tomorrow. Hypothetical propositions are if and then, if something happens, then the other thing or the result or the conclusion will follow. Disjunctive propositions give us 2 options, that there are probably 2 things, that one of the 2 things which happened. That's why they are called disjunctive. Okay. So now let's come back here. Categorical syllogism. Deductive reasoning using statements that categorize subject and predicate. Okay. So when we say all cats are mammals, the first, cat is your subject and mammal is your predicate. In normal English grammar, the first doer is always subject and the later part is all predicate. So similarly here, cat is the subject and mammals word is the predicate. It is a deductive kind of syllogism because deductive reasoning is used, obviously. Ignore this for now. Major premise, minor premise. All cats are mammals. All mammals are animals. Therefore, all cats are animals. This is called categorical syllogism or categorical proposition. Hypothetical syllogism uses if-then conditional statements to draw a conclusion. It is also deductive. If P happens, then Q. If P is true, then Q is true. Okay, this is called modus ponens. That if P is true, then Q is true. Another is if P, then Q. If Q is false, then P is false. I'll give you examples of both. The first one, if P is Q, if P, then Q. If P is true, then Q is true. If it rains, the ground gets wet. It rains, therefore the ground is wet. Now let's go to the second, modest tolerance. If it rains, the ground gets wet. The ground is not wet, therefore it has not rained. Q is false. The ground is not wet, therefore P is false. Therefore, it has not rained. These are hypothetical syllogisms. Clear with these three concepts? If you want, I can give you 1 or 2 minutes to let it all sink in. Clear with the concept? Clear? Next, based on whatever we have done so far, questions based on that? Match A with B? Statement, premise, conclusion, argument. And description is given. You have to match. The answer is 2. See, statement is a sentence that can be viewed as true or false. Premise is the reason why we should accept another statement or conclusion. It's the starting point. Premise is the starting point. It gives you the reason why you can accept the conclusion. Conclusion is a statement in the argument. Argument is made up of premise and conclusion. So it is that statement that is intended to be proved, or it is a statement that is supported by the premises. And last one, what is argument? A group of statements intended to prove or support another statement. Next. What can be inferred from the following? Because x is equal to 3 and y is equal to 5, then x plus y is equal to 8. What is it among the given options? Okay. It is a deductive argument based on mathematics. Next, which of the following is not a common pattern of deductive reasoning? Okay, predictive argument is your answer. The rest of the three are deductive. Definition is deductive. Next, which among the following can be, what among the following can be claimed of deductive argument correctly? So which are these are characteristics of deductive arguments? These questions have been asked in the current last few years. They are not very obsolete. Nowadays, such kind of questions are asked a lot. So that's why you need to be clear in your concepts. So what's the answer here? 1, 2, 3, or 4? Which combination of statements is your answer? The answer is 3. Why? It's the usage of words. See, it's saying probably. Where do we use the word probably? Inductive reasoning, not in deductive. Deductive talks about must be. There's no probably when it comes to deductive reasoning. It is true or false. Again, unlikely or likely are the words used for inductive reasoning. Here, if you see, there's a lot of certainty when it comes to deductive reasoning. See, from the point we started, truth preserving. Okay, there's a lot of certainty. It is certain and logically valid. That is how deductive reasoning is. So your answer is B, D, and E. Clear with the concept? Clear? Okay. Moving on. What can be inferred correctly from the following? Okay. Science is based on experiment, on a willingness to challenge old dogma, on an openness to see the universe as it really is. Accordingly, science sometimes requires courage, at the very least, the courage to question the conventional wisdom. There are two premises. there's a statement that says it's just an illustration, it's just an example, and there are two conclusions. Out of this, which combination of statements do you think is true? Science is based on experiment as a willingness to see the universe as it really is your starting point, is your premise. The conclusion is that science sometimes requires courage. That is your inference here. Okay? First comes the premise, then comes, because here if you see the word accordingly, based on the previous statement, science sometimes requires courage. Why? Because it is based on experiment, on a willingness to challenge something, on an openness to see. So for that, what do you require? Courage. That is the reasoning which is given in the example here, or rather the question here, not example. That's a different option. Another question. Observe the following argument and find the correct form. A has characteristics of X and Y. B has characteristics of X and Y. A has characteristics of Z. Therefore, B has characteristics of Z. What kind of argument is this? Statistical, argument from authority, mathematical argument, or argument from analogy? No one thinks it is mathematical argument because it has A, B, X, Y? Okay. So you're right. The answer is argument from analogy. See, you can look at this statement as A equals to XY, B equals to XY, A equals to Z, therefore B equals to Z. It's an analogy. Identify the pattern of the argument in the following. Habits are like a cable. We weave a strand of it every day, and soon it cannot be broken. Causal argument, argument from analogy, argument from authority, argument from definition. For those who say one, I want you to tell me what's the cause in this causal argument. What is the cause? You can speak up, you can write in the chat. If it's a cause, what's the cause, what's the impact? Anyone can share what's the cause, what's the impact. Habits are like a cable. They are strong enough. What's the cause here? When you think logically, there has to be a logic. I want to know what was the logic that you thought of so I can tell you how it is wrong. If you don't want to share, your loss, not mine. It's an analogy argument. The word like is very clearly helping it. So that's what I'm saying. Consequence here, what is the consequence of what? If it's a causal argument, then here what dash is the consequence of dash. What will come in those two blanks? For those who think it's a causal argument. Anyways, the answer is argument from analogy. If you don't share your doubt, I cannot solve it. Sorry. Next. Doing something on repeat. Causal. Cause is, if I say this statement is based on cause, I have to be logically clear saying dash is the cause of the dash. It rained today morning, so the ground is wet. Rain is the cause of wetness. Dash is the cause of dash. Okay? That is what I was asking. Anyways, what can be correctly claimed about the following? It's an argument, non-argument, non-argument but an explanation, non-argument but an illustration. So I ate because I was hungry. Good. The answer is 3. It's not an argument. It's an explanation. See, argument, explanation, and illustration. What's the purpose of argument? To prove something. Should I believe this? Should I not believe this? Premise and conclusion. The conclusion is debatable or not yet accepted, and that is why you are giving an argument. For example, I am hungry, so I should eat something. Explanation is given to clarify why or how something happened. The key word is because. Why did this happen? How does this work? So from a known fact to a reason or cause. The statement is already accepted as true. Like I ate is already accepted. Now all that's remaining is the reason, an explanation, because I was hungry. Illustration is example. To show or demonstrate the idea with examples, the keyword is for example. What does this look like? There's a claim and there's an example to explain it. The statement is assumed to be true and the example just helps to clarify it. It does not give more proof. People often snack when hungry. For example, having chips in the evening. This is an example for an example. Okay. Next question. What can be correctly inferred from you know how I know animals have souls? You know how I know animals have souls? Because on an average, the lowest animal is a lot nicer and kinder than most of the human beings that inhabit this earth. Choose your option. If it's a premise, if it's a conclusion, if it's not an argument. Great job. Great thinking, going in the right direction. The premise is the lowest animal is a lot nicer and kinder than most human beings that inhabit this earth, which leads to the conclusion that animals have soul. Here we are not talking about whether it is valid, cogent, whether it is strong, or something of that sort, or whether it is sound. Here we are just talking of the structure. Okay, so the answer is 3, A and E only. It is not essential that the premise has to come first in the description, but when we are thinking, it has to come first, followed by the conclusion, the logical sequence. It is an argument, of course. That's why A and E is the option. Why is it not an argument? The lowest animal is a lot nicer and kinder than most of the human beings that inhabit this earth. That is why they have souls. That is why the second premise could be that nicer and kinder beings have souls. Therefore, the conclusion is animals have soul. But that second premise is not given here. So, we cannot choose that option. Clear? Okay. Moving on to the next topic, syllogisms. But here we are just starting with the basic, concepts of syllogism, and we will go to the, today we'll talk about, that is also syllogisms only, come on. It's very difficult for me to, go in, all the concepts here are interconnected in such a way that you can't have one single linear flow. So syllogism will again be introduced tomorrow at 6 p.m. again. Okay, so for now, syllogism is a deductive argument, okay, consisting of 2 premises, 1 conclusion, where each statement is a categorical proposition and they share 3 terms. Ideally, syllogism is a deductive argument consisting of 2 premises and conclusion. You know what is deductive argument? You know 2 premises. What are premises? You know what's a conclusion. You know what's a categorical proposition, which divides things, which talks about 2 different categories. And they share 3 terms. Okay. We already saw the next slide. 3 kinds of propositions: categorical, hypothetical, and disjunctive. Next, when we said 3 terms in syllogism, what are these 3 terms? Major term, minor term, and middle term. In this slide, let's look at the theory, then we will see examples also. Now, subject is the first part, predicate is the last part. Keeping that in mind, major term, T, is the predicate of the conclusion. Premise 1, premise 2, conclusion. Major term is the predicate of conclusion. It is also found in the major premise. That is the first premise. Now, it could be the predicate or the subject of the major premise, but it is there. But it is definitely the predicate of conclusion. Second, minor term or S. It is the subject of conclusion. It is found in the minor premise. It could be the subject or the predicate. It is found in the minor premise. Okay. Major term is found in the major premise and is predicate of conclusion. Minor term is found in minor, second premise, and is the subject of conclusion. Middle term is something that links both of them. It appears in first and second, both major premise and minor premise, but it does not appear in the conclusion. It links the major and the minor terms together logically, but it does not appear in the conclusion. Okay. Let me see if there's an example. Yeah. See, let's see the example here. All mammals are warm-blooded. Okay. All dogs are mammals. All dogs are warm-blooded. Now here, predicate of the conclusion. Warm-blooded is your major term. Warm-blooded, as you can see, is also there in the major premise. Okay. Dogs is the subject of the conclusion. It is also there in the minor premise. The middle term, mammals, is there in both major and minor premise, but it is not there in the conclusion. Clear with major term, minor term, and middle term? I'll show that slide again. The predicate of conclusion found in the major premise. That's a major term, P. Subject of the conclusion, because it's the subject of conclusion, it's called S, and it is found in the minor premise. Middle term is M, appears in both premises, not in the conclusion. It links major and minor terms together. You have to be very, very clear about what is major term, what is minor term, and what is middle term, because tomorrow's entire 2 hours are going to depend on these three things. We'll talk about rules of syllogism and we will talk about fallacies. All that entire is based on these three terms. Okay. If you don't know what are terms and if you don't know what's distribution, which we are going to take next, today what we are doing is learning the major concepts. Tomorrow we'll learn more rules based on these concepts. Okay. So if someone is not clear, let's take one more example. No reptiles are mammals. All snakes are reptiles. No snakes are mammals. Okay. Here, mammals is the predicate of conclusion. It is there in the major premise. Snakes is the subject. I don't even know why have I, just because it's mammals. Snakes is there in conclusion. Snakes is there in minor premise. So it is the minor term. Reptiles is there in major premise and minor premise. It is the middle term. It is not there in the conclusion. Okay. You can take a screenshot of this if you want. Please ask if you have doubts.
One question. Can we go back to the previous slide once?
This one?
Yes, ma'am. Here, both the premises have reptiles. So the reptiles appear in both the premises. So directly it becomes the middle term.
So that is the middle term. It links the subject and the predicate, but it will not be present in conclusion.
Here the mammals come first, right? So mammals will be the major term directly.
No. What is the conclusion of this predicate of the conclusion is your major term. It could either come first or second in the major premise. That is not the point. The point is it is the predicate of the conclusion. It is the predicate of the conclusion. In the conclusion, first you will have subject, which is your minor term, and the predicate, which is your major term. Okay. This is your subject of conclusion. So that is your minor term. This is the predicate of the conclusion, so that is your major term. The minor term will be there in the minor or the second premise. The major term will be there in the major premise or the first premise. Middle term will not be there in conclusion, but it will be there in both premises as it links the subject and predicate, or the major term and the minor term. Clear? Okay. If anyone wants me to explain this once again, tell me, because everything that we do talk about forward tomorrow is going to be based on this. I think I'll talk about it once again tomorrow also. Okay. So logically, both these examples are valid and sound. Okay. Next, distribution of terms. So distribution of terms means, let's say you have 30 students in the class and 30 chocolates. You distribute one chocolate to each student. So that means the chocolates are distributed. All of them are given, done. So it is distributed. There are 10 books and 5 students. Okay, 7 students. There are 10 books and 7 students. You distributed 7 books, but 3 are still remaining. So you cannot say that the books are distributed because 3 are still remaining. So the books are undistributed. If you have distributed all of it, then it is distributed. If something is remaining, it is undistributed. Okay. There are 0 students. All the books are still with you. So no books are distributed. No books have been given to students. Then also those books are undistributed because non-books are given to students. Okay. You will understand it as I show you with examples. A term is distributed when it refers to all members of the category it names. If the term is talking about every single member of the group, it is distributed. If it is talking about some or half or maybe or an unknown number, it is not distributed. All is distributed. Let's see how. So I have created Venn diagrams to make you understand these concepts. Okay. And it will also probably help you understand how you can draw Venn diagrams from statements. All cats are animals. Here the subject is cats, predicate is animals. Okay, in the statement, all cats are animals. So we are talking about each and every cat. That is why it is distributed, because we are talking about all the cats. But we are not talking about all the animals. We are only talking about a small portion of animals, which is cats. We don't know anything about the rest of them. So animals, here the predicate is not distributed, because we are not saying all animals are cats. We are just saying that cats are a part of the animal group, but we don't know something which is about the entire animal group. Clear with this? Everyone has to be clear with this, not just one person.
Yes, ma'am.
Others? The usual names are missing. Okay. Okay. So see, all cats are animals is called, yes, I will explain again. Because these 4 kinds of statements are whatever we are going to study in this hour is going to be your basis of understanding for everything that's going to happen tomorrow. And if these concepts are clear, you will be able to at least solve 2 logical reasoning questions in your exam without any preparation. Okay, all cats are mammals. You didn't understand? Or wrong smiley by mistake? All cats are animals. In this statement, all the cats are animals. So just as I said that if all chocolates are distributed, only then it can be said distributed. If some chocolates are remaining with me, it cannot be said distributed. Here, all cats are animals. Animal is an attribute which is given to all the cats. So the cats are distributed. The subject is distributed here because we are talking about all cats. However, when we are talking about animals, we are talking only about a small section of animals, which is the cats. We are not talking about all the animals. And that is why animals is not distributed, because we are not talking about all the animals. Now clear? Okay. This type of statement, all cats are animals, all A are B, is also called A-type statement. A for apple. Next, no dogs are reptiles. No dogs are reptiles. Now here, we are talking about all the dogs. That all the dogs are not reptiles. And we are talking about all the reptiles. That all the reptiles are not dogs. This is a quality which we are talking about for all dogs. All dogs are not reptiles. Because all dogs are not reptiles, all reptiles are also not dogs. That is why here both subject and predicate are distributed. We are referring to all dogs, that no dogs are reptiles. And we are also referring to all the reptiles, denying that all the dogs do not belong in that entire group of reptiles. Dogs do not belong to the entire group of reptiles. To make that kind of universal exclusion, you are talking about all members of both the groups. And that is why here both subject and predicate are distributed. Clear with this? It is called E-type statement. Okay. So again, all cats are animals. We are talking about all cats. It is distributed. Animals not distributed. Here we are saying no dogs are reptiles. So no dogs, no reptiles. That means all dogs are not reptiles. All reptiles are not dogs. Both of them are, we are talking about both all the members of each group. It's an E-type statement. And here both subject and predicate both are distributed. Okay. Next. Some peacocks are red. Some peacocks are red. With the statement, some peacocks are red, comes 3 possibilities. Here, the last one is the only thing that we visualize, that some peacocks are red. Okay? So if we are talking about some peacocks, then we are not talking about all peacocks. So peacocks is not distributed. Again, only some peacocks are red. So we are not talking about all red beings. So that is why the predicate red is also not distributed. As per the statement. When some is there, we cannot say that it is distributed. Okay. Now, when we say some peacocks are red, it is possible that some peacocks of this all peacocks are red. This possibility is there, but we are not sure. Another possibility is some peacocks are red, but all red are peacocks. That is third possibility which arises, but we are not sure of it. It is called I-type statement. I'll repeat the entire thing again from the beginning. Some peacocks are red. When we talk about some peacocks are red, what comes first in our mind is this, that some peacocks are red, there is an overlap somewhere. But because it is talking about some peacocks only, it is peacocks cannot be said to be distributed because it is not talking about all peacocks. And because it is not talking about all red beings, only about some peacocks who are red, again, red also cannot be considered distributed. So here peacocks and red, subject and predicate, both are undistributed. Now, when it comes on how to solve questions or how to create Venn diagrams from such statements, there are three possibilities while solving logical reasoning questions based on this statement, that some peacocks are red. Some peacocks are red could mean this, the one which we think is, but for this statement, for this figure, all peacocks are red. If all peacocks are red, then some peacocks are also red. So some peacocks are red can be true for this figure also. Now here, if all red are peacocks, then also some peacocks are red. So some peacocks are red can be true for this figure also.
Ma'am, that is more, I feel that is more appropriate. The second figure, some peacocks are red. Second figure, generally peacocks are blue. Some peacocks are red. So second figure actually fits the argument, right?
That's what we are talking about, truth. But when we have to solve questions based on syllogisms, then some peacocks are red. Now, instead of peacocks, if I say some unicorns are red, unicorns do not exist in this world. Now, the problem of blue peacocks is gone. So let's say some unicorns are red. Now, no one can tell whether unicorns are red or silver or rainbow or God knows what colors they come in. Some unicorns are red. Now, we have three possibilities. Only some unicorns are red, and only some red beings are unicorns. Second possibility, all unicorns are red, but all red beings are not unicorns, which is the first figure. And third possibility, some unicorns are red, but all red beings are unicorns. So when the question or a statement, I-type statement, some peacocks are red or some A or B is there are always three possibilities in Venn diagrams. Okay. See, not everyone solves questions using Venn diagrams, but in competitive exams, like here we have easier questions, more theoretical questions if you know the concepts. When it comes to competitive exams where you have to solve things like, what do we say, those sitting arrangements and those kind of questions, we try to make figures and create possibilities so that no possibility remains left out. So there, when such statements are given, these are the three figures that I would draw. Of course, there would be a second premise after this, which would remove one or two of the figures. But here we have only one statement. So based on this statement, three figures are possible. There are three possibilities. Now the second premise would tell me if there are two possibilities remaining or just one single possibility and what is my conclusion. But here, based on this premise that some peacocks are red, there will always be three possibilities. Clear? This is called an I-type statement. So we have A, all A are B, E, no A are B, I, some A are B. And here both subject and predicate are not distributed because you are not sure which of the possibility is true. Okay. And the fourth and the last type of statement, some A are not B. All A are B, no A are B, some A are B, some A are not B. So when I say some A are not B, so here let's say some rabbits are not cute. That gives me two possibilities. Some rabbits are not cute. So then it could mean here I couldn't draw the overlap. So some rabbits here, there is an overlap of rabbit and cute here. Here there is an overlap. So let me draw it somehow. Okay. So let's say this is an overlap of rabbit and cute. Okay. So some rabbits are not cute shows this. These rabbits are not cute. So now we have two possibilities. Some rabbits are cute or all rabbits are not cute. We do not know which one is true. But here, here we are talking about the fact that these rabbits, my subject, what is my subject? My subject is not these rabbits. My subject is these rabbits, which are in red color. These rabbits are not there in the entire group of cute beings. It would take a moment for you to understand. Think again. Our subject is these rabbits, not the common rabbits. These rabbits. In this possibility, there are no common rabbits. So these red rabbits, which are not cute rabbits are not there in this entire group of cute beings. So this entire group of cute beings, which is my predicate, cute, is distributed. These red rabbits, the not cute rabbits, which are my subject, are not there in this. They are not there in this. That is why my blue is distributed. My cute beings, the predicate here, in some A or not B, is distributed. Because I am making a statement about the whole group of cute beings by excluding some non-cute rabbits. My subject is non-cute rabbits. My subject is not rabbits. Okay? The subject rabbits is not distributed because we are not sure if all rabbits are not cute or just some rabbits are not cute and some are cute. So because we are talking about some rabbits, not all. To say some S are P are not P is to deny that S belong to the entire P group. So our subject is this, the not cute rabbits. They do not belong to our predicate, which is cute. So you must be referring to all of P to exclude from it. And it is called the O type statement, A-E-I-O. They don't have a fifth one or they would have used U. Take a minute to think over this. Then I'll repeat it again. And they take another minute to think over it. And then ask me if you have a doubt. For those who already know this, maybe it's a repetition, so it's easy for you to understand. But for those who are probably attempting it for the first time, I resonate. Because when I learned it for the first time, it took me some time to digest, especially this one. Okay. So again, Some A are not B. Some rabbits are not cute. Here, this not cute rabbits is our subject and cute beings is our predicate. Subject rabbits is not distributed because we don't know if all rabbits are cute or not, or some rabbits, if all rabbits are non-cute, some rabbits are non-cute, we have no idea. Both possibilities exist. So they are not distributed. We are only talking about some rabbits. But these non-cute rabbits do not exist in the cute predicate, and that is why it is distributed. We are making a statement about the whole group of cute beings by excluding the not cute rabbits from it. It's called O-type statement. Some S are not P. Clear with this? Clear? Not clear? If it's not clear, just say not clear. You can ask your doubt as someone asked. If you have a suggestion about rabbit and their colors, also give that so that I can know where I made a mistake in giving an example. I'll keep in mind, I'll change those peacocks to unicorns so that that doubt does not occur again. My bad. I'm sorry. This is a quick recap of all 4 kinds of statements. Okay. Now, A-type statement, all A are B, is called universal because it talks about all and it says all A are B. So that is why it is called affirmative. Is the subject distributed? Yes. Predicate distributed? No. All cats are animals. E-type statement is the universal negative. No cats are reptiles. Is the subject distributed? Yes. Predicate distributed? Yes. I kinds of statements, wherever you have some are, some are not, it is called particular. It is not about universal. It is not about all or none. Particular affirmative, here both subject and predicate are not distributed. Some cats are white. We have no idea about other cats and we have no idea about other whites. Particular negative, some cats are not white. Here, the subject is not distributed because we are talking only about some cats, but the predicate is distributed because we know that these non-white cats are not there in the white beings. That is A, E, I, O, and they are a basis of lot of rules in logical reasoning syllogisms. Universal affirmative, universal negative, particular affirmative, particular negative. Clear with this concept of A, E, I, O, universal affirmative, negative, particular affirmative, particular negative distribution? And clear with the fact that there is a major term, minor term, and middle term. Okay. Next, the next concept is immediate and mediate inference. Mediate inference, we'll just see what it is, but we'll talk about it tomorrow. Today, we'll talk about immediate inference. But what is that? Inference, as I started in the beginning of today's session, is the mental process of drawing a conclusion based on evidence or reasoning. There are dark clouds in the sky, so our inference is it's likely going to rain. The streets are white and people are carrying umbrellas. It probably rained recently. This is what we saw in the beginning of session. Now, the difference between mediate and immediate inference is how many premises are used to arrive at conclusion. When only one premise is used, it is immediate inference, immediately. That's how I remember. That immediate means instantly it happened in just one premise. Mediate, it required 2 or more premises. But in categorical syllogisms, we have only 2 premises. An immediate inference is drawn from a single premise without needing a second statement. Only one proposition is used to reach the conclusion. All roses are flowers, so some flowers are roses. Okay? No dogs are cats, So no cats are dogs. We just used one statement and transformed it logically. And both these conclusions are true. Whereas in mediate inference, we use at least two premises. The favorite one. All humans are mortals. Socrates is a human. Therefore, Socrates is a mortal. Here we use two premises. So by combining two or more premises, when we draw the conclusion, it is called mediate inference. But what we are going to talk about now is the immediate inference. Mediate inference we'll talk tomorrow. Why do we need to study here? In UGC NET exam, immediate inference shows up in conversion, obversion, contraposition. And mediate inference shows up in syllogism questions where you have two premises and a conclusion, and then you are asked things based on that. And Venn diagram based reasoning. But in recent years, Venn diagrams have not been asked. I taught you Venn diagrams so that for syllogism questions, one way to solve the question is draw Venn diagrams, see whichever fits, and then reach your conclusion. Another way is analytical, where there are rules and regulations, and based on those rules, based on the terms and rules, you solve the question. So Venn diagram based reasoning, we'll take one or two examples tomorrow, but Venn diagrams, how to draw, I have taught you today. Syllogism based questions, the analytical ones also we'll discuss tomorrow. Today we'll talk about conversion, obversion, and contraposition, the immediate reasoning. But before that, the major difference between immediate inference and mediate inference, if you just want to take a screenshot of this slide. Clear with what is immediate and mediate inference? Okay. See, I'm asking you after every concept, because this is not like the theory, very katha going on. If you miss out a topic, you read it and you do it on your own. Okay. So that's why I keep ensuring that we are on same page. Now see, there's a concept called square of opposition. Okay. AEIO, all these four statements, all ARB, no ARB, some ARB, some AR not B. All these four statements, how do they relate to each other? How do they agree, disagree, or contradict each other? The square of opposition has four relationships between these statements. These four relationships are called contradiction, contrary, subaltern, and subcontrary. This is how it looks. Here you see A statement. You just find a pencil or something. So see, this A, every S is P, every subject is predicate. E, no S is P, no subject is predicate. I, some S is P, and O, some S is not P. This is the positioning of A, E, I, O in the square. Okay, first you need to remember that it doesn't go circle, it goes straight. A, E, and then I, O. It's not circular. It's A, E, and then I, O. It's linear, horizontal. Now let's go for the first relationship. Contradictories. The relationship between A and O and E and I is that of contradictories. So what is that? Contradiction means always opposite. Okay? A versus O and E versus I. If one is true, then the other one is false. If all S are P, that is A, then some S are not P is false. For example, All fruits are sweet. Some fruits are not sweet. If A is true, O is false. If O is true, A is false. Only one of them can be true. E versus I. No SRP, some SRP. No drinks are sour. Some drinks are sour. If E is true, I is false. If I is true, E is false. Clear with the concept of contradiction? Okay. So their relationship is here. Here. The crisscross. AEIO. And in that, here lies contradictories in the center. The next relationship is contraries. Remember, this is contradictory. This is contrary. Okay? Contraries. This relationship is between A and E. Both cannot be true at the same time. All dogs are friendly. No dogs are friendly. Either A is true or E is true. But here it's again not either or. It's not an opposite relationship. What if only some dogs are friendly? Then both can be false. Both can't be true, but both can be false. That relationship is called contrary. Both can't be true at the same time, but both can be false at the same time. That is contraries. Both cannot be true at the same time, but both can be false at the same time. The next relationship is subcontraries. That is between I and O. Some kids are quiet, some kids are not quiet. Both can be true at the same time, but both cannot be false. At least one has to be true. Both can be true at the same time, but both can't be false. That is subcontraries. Here, both can be false, but both can't be true. The exact opposite. Both can be true at the same time, but both can't be false. At least one has to be true. In I and O. Clear with this? Contradictories, contraries, and subcontraries. This is the example for contrary. Showing you again. This is the example for subcontrary, I and O, the lower one. And the last one, subalterns. This relationship exists between A and I, E and O. Now here, the relationship is truth downwards, false upwards. If A is true, I is true. If I is false, A is false. Truth downwards, false upwards. From up to down, if A is true, then I has to be true. And if I is false, then A is false. Similarly here, if E is true, O is true. If O is false, then E is false. I'll show you the example. If all A or B is true, then some A or B is also true. But if some A or B is false, then all A or B must be false too. Truth flows down, false flows up. Similarly here, if no S is P is true, then some S is not P is also true. But if some S is not P is false, if some S is not P is false, that means some S is P. So if some S is not P is false, then no S is P is also false. Clear with subaltern relationship? Okay. So just to repeat again, contradictories, AO, EI. First of all, you need to remember AE and then I and O. That's how they go in a line. AE and then in line below I and O. A is every, E is no. This is some A is, some A is not. Criss-cross relationship in center is contradictory. A is contradictory to O, I is contradictory to E. The second relationship is contraries. A and E are contraries. Both cannot be true at the same time, but both can be false. I and O are subcontraries. Both cannot be false at the same time, but both can be true at the same time. And subalterns, if A is true, I is true, but if I is false, A is false. If E is true, O is true, but if O is false, E is false. Truth flows down, false flows up. This is the entire square of propositions. Clear with this entire squares concept? Yep. So you can take a screenshot of this for a quick recap. Okay, so let's solve few questions based on this. Which of the following statements are true regarding subcontrary propositions? If one is true, the other must be false. They cannot both be false. If one is false, the other must be true. They can both be true. Which of these are correct for subcontraries? Okay. So see, we are talking about subcontraries here. This. Some S is P, some S is not P. Both can be true, but both cannot be false. If one is false, then the other has to be true. Okay, that is the relationship. So here the answer is 2. If one is true, the other must be false. No, the other can also be true. That's for the contrary, not subcontrary. They cannot both be false. If one is false, the other has to be true, but they can both be true. So B, C, and D is your answer. Next. If the statement, some birds are not mammals, is given as true, which of the following statements can be immediately inferred to be false? The answer is 4. We'll solve this 2 ways. Okay. Some birds are not mammals, right? Okay. So let's say these are birds. And these yep, are mammals. Okay. Now, some birds are not mammals, which means there are 2 possibilities. Some birds and mammals do not overlap, or some birds and some mammals overlap here. Okay, there's an overlap. These are the 2 possibilities that exist from this. Some mammals are not birds. Some birds are not mammals. So some mammals are not birds is automatically true from both the diagrams. Some birds are mammals is a possibility. We cannot say that it is true, but that possibility does exist, which we can see here. No birds are mammals. That is also a possibility that exists, which we can infer in this Venn diagram. So the only possibility that does not exist is all birds are mammals. Okay? This is using Venn diagrams. Now, using this, some S is not P. Okay? Some S is not P. Here, both can be true. Here, if this is true, then this may or may not be true. That is not given. But one confirmed contradiction is this. Every S is P. So using this, we can know that if O is given, then its direct contradictory is A. That all S is P or every S is P. Based on that, the only possibility that remains here is all birds are mammals. So both the ways you can solve the question. This is how you have to think while you are solving this logical reasoning questions. Clear with this? We will solve only questions based on this and end the session. The 3 concepts of conversion, aversion, we will take tomorrow. Okay, contraposition, aversion. No monkeys are feline. If this statement is given, then which of the statements is true? Which of the statements can be inferred to be true? See, no monkeys are feline is an E type of statement. So if E is true, then A may or may not, then A has to be false, confirm, because both of them are contraries, both of them cannot be true. So A is gone. Now with E and I are contradictories. So if E is true, I has to be false. So I is out of option. Now only O type statement is a subaltern where truth flows downwards. If no monkeys are feline is true, then some monkeys are not feline. O type statement is true. I'll show you that in the square. Here, subalterns. The truth flows downwards in subalterns. So if E is true, then O is true. No S is P, some S is not P. Based on that, your answer has to be 4. Clear with this? Okay. Let me see how many questions are left. Just 2 questions. Okay. And then we'll end the session. Which of the following 2 statements cannot both be true, but both can be false? All monkeys are apes, some monkeys are apes, some monkeys are not apes, no monkeys are apes. They both cannot be true together, but both can be false together. Which relationship is that? It's the relationship of contrary. A and E. Both cannot be true together. One has to be true, one has to be false, but both can be false. That's a possibility. So that is why your answer is 1. All monkeys are apes and no monkeys are apes. They both cannot be true, but both can be false. And the last question for today's session. 2 propositions are contradictory. If contradictory means they cannot both be true, of the pair exactly one is true and exactly one is false. They can both be false. They cannot both be false. Contradictory is what comes in between, crisscross. One is true, one is false. Like dark and light cannot be together. They both cannot be true, they both cannot be false. Only one is true or one is false. They can both be false does not exist for contradictories. And that is why your answer is A, B and D only. That ends our today's session.